Here's my quick walkthrough to this math method example 1. So the first one is a product rule. dy dx equals to 2x cosine of x plus x squared times negative sine x. Tidy up that a little bit, you get a 2x cosine of x. Take away x squared, sine of x. Next one, find the gradient of the tangent to y equals to f of x at x equals to 8. So we'd like to get f dash of x equals to 6 times 1 over 2 square root of x plus 1 plus 0. So that will be 3 divided by square root x plus 1. And then substitute 8, you get 3 over square root of 8 plus 1, that's 9. So 3 divided by 3 is 1. So that's the final answer. Question 2, notice the domain restriction is x greater than 3 over 2 minus 3 over 2. So when you antiderive this reciprocal function, you get a, let's say, log function. So g of x is an integral of 1 over 2x plus 3 dx. Don't forget about the dx. So you get a half log e of bracket 2x plus 3 at c. And therefore, you can sub in g1 equals to 0 to find the integration constant c. When you sub in 1, you get a half log e2 plus 3, that's 5 at c. So c is actually negative half log e of 5. Don't forget to specify g of x as a rule here. That is a half log e 2x plus 3, take away half log e of 5. Or you can combine that. I'll put some equivalent forms here. G of x equals to half log e 2x plus 3 divided by 5. Or you can move the half into the argument and get log e of square root 2x plus 3 divided by 5, close bracket. So that is question 2. Question 3, state the range of f. This is a circular function, 0 to 2 pi. Notice the period is 2 pi over 2, that is pi. So the given domain covers 2 cycles. Therefore, it is enough for us to say, okay, the range of f is the center line take away amplitude and the center line plus amplitude. And as an interval, that is minus 1 to 3. Or you can say minus 1 less than or equal to f of x less than or equal to 3. The next thing is solve f of x equals to 0 for x. Notice the angle is the double angle, not a single angle. So you need to work out the working domain. For example, x between 0 to 2 pi, so 2x is between 0 to 4 pi. And therefore, you can equate the whole function to 0 and do some rearrangement. Like cosine of 2x equals to minus half. Therefore, your 2x, we select the angles within 0 to 4 pi. Like negative half gives you, let's say, 2 pi over 3, 4 pi over 3, I suppose. And we might have, let's say, 2 pi over 3 plus 2 pi. That is, let's say, 8 pi over 3. And 4 pi over 3 plus 2 pi, that is 4 plus 6 pi over 3. So you get a 10 pi over 3 only. Because for 2 cycles, you expect totally 4 solutions. You don't need any other solutions. Well, you could use general solution method to tackle this problem, but eventually the answer should be the same. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so that is the end of the problem. Sketch the graph y equals to f of x for x between half pi to 3 pi over 2 on the axis below. Notice 0 to pi is 1 cycle. So for example, if I divide, let's say, each grid into 3 further pieces, like pi over 6, etc., etc. So now 1, 2, 3, 4, 5, 6. Okay. If you want, let's say, pi over 3 is here, 2 pi over 3 is here. I'll put some crosses here. And you also have 4 pi over 3. That is, let's say, here. And finally, 5 pi over 3 is here. But the problem is we only look at half pi to 3 pi over 2. So Let me just do a quick sketch and then do some amendments. So for example, a cosine graph, that's the middle, 1, highest is 3, lowest is -1, in the middle of a pi on 2 to pi, and the highest point in the middle of pi to 3 pi over 2, here, and the 3 pi over 2 is the lowest, here and here. But eventually, after you join everything like that, you just need the middle section, okay? So for example, I can just ignore this bit and this bit, okay? Let me use a pencil. Something like that, like that. Like that, and that. Make sure you show the correct curvature around each point, and I'll just label the endpoint. This is 3 pi on 2 minus 1. This is pi on 2 minus 1. The middle you have pi comma 3. And they were not required the x-intercept, but I'll just label them. So for example, I would label, let's say, 4 pi over 3 comma 0, and this will be 2 pi over 3 comma 0. So basically that is the graph I'll be producing on, let's say, a physical booklet. Question 4, show that k equals to 10 or k equals to 15. So basically sum up the probability 4 over k plus 2k over 75 plus k over 75 plus 2 over k equals to 1. So 6 over k plus 3k over 75 equals to 1. And then you'll be able to get, let's say, 6 over k plus k over 25 equals to 1. And you can combine, let's say, the two fractions, like 6 times 25 plus k squared divided by 25k equals to 1. Therefore, you get a k squared plus 150 equals to 25k. Eventually, you'll be able to get a k squared minus 25k plus 150 equals to 0. So the first thing is k minus, let's say, 10. The other thing is k minus 15 as a factorized form. And then you'll get a k equals to 10 or 15. Also do a quick check. All of these values must be positive between 0 and 1 because they are probabilities. You can mention, let's say, checking k equals to 10, the probabilities are 4 over 10, 20 over 75, 10 over 75, that's fine, less than 1, and a 2 over 10. You don't have to simplify them, in my opinion. And checking k equals to 15. So the probabilities are, let's say, 4 over 15. The last number is 2 over 15. And 15 divided by 75 is 1/5, so you have 2 out of 5. And also, let's say, 1 out of 5. So eventually, all the probabilities are valid. Therefore, k equals to 10 or k equals to 15. The next thing is, if you have, let's say, k equals to 15, we already calculated the 4 probabilities. So probability of x greater than 1 equals to probability of x equals to 2 plus probability of x equals to 3. Let me double check. Yep, only 2 and 3 are larger than 1. So this is probability x equals to 2. This is probability x equals to 3 under the case k equals to 15. Therefore, 1 over 5 is 3 out of 15 plus 2 out of 15. So that'll be 5 out of 15, and then you get a 1/3, something along this line. And notice this part of B has a same condition for both subplots. Therefore, to calculate the expected value of x, I'm going to multiply the x value by the probabilities. So for example, 0 times 4 out of 15 plus 1 times 2 out of 5 plus 2 times 1 out of 5 plus 3 times 2 out of 15. So eventually you get a 0 plus 2 plus 2, that's 4 out of 5. Let me just write that properly. 4 4 divided by 5 plus 6 out of 15. So eventually this thing can be simplified to, let's say, 2 out of 5. Therefore you get a 6 out of 5. Therefore mu equals to e to the power, expected value of x, 6 over 5, or you can write like 1 and a 1/5 or 1.2. So that is a very simple probability question. Then if you look at question 5, this is a very simple industrial equation, e to the power x squared minus 8 times e to the power of x plus 7 equals to 0. So we factorize with respect to e to the power of x, and you can have a -1 here and a -7 here. And e to the power x minus 1 times e to the power x minus 7 equals to 0. So one case is e to the power x equals to 1 and x equals to 0. The other case is e to the power x equals to 7. That's a valid equation as well. So we have x equals to log e of 7. Or you can write ln of 7. The next thing is the g of x. From memory, some textbook questions involved a graph like that. So it's a sum of two exponential functions, and this 7 eventually will be a horizontal asymptote, like y equals to 7. Because the graph has a single, let's say, stationary point, a local minimum. We want to find this local minimum, and also notice the graph is cutting through 0 here and cutting through natural log 7 here. So I suspect the graph may look like that. Eventually I want to find, for example, the location of this stationary point and get the domain restriction to -infinity to a. This is the largest value of a at the stationary point. So the graph is 1 to 1. Let's say g dash of x equals to 2e2x minus 8ex, and factorize out 2e to the power x, e to the power x minus 4 equal to 0. Notice e to the power of x is greater than 0, so we only have ex equals to 4. And the x equals to log e of 4. If you wish, you can write it like 2 log e2. But eventually I just write a equals to log e4. Because the question wants the value of a rather than x. We need to answer the question specifically. Binomial random variable, n equals to 6, p equals to 1/4. So q equals to 3 out of 4. The variance of x is simply mpq. And that is 6 times 1/4 times 3 out of 4. Then you can cancel out, let's say, a 2 here. Eventually, you should be able to get a 9 out of 8, or 1 and a 1/8, or 1.125. Something along this line. Next thing is calculate the probability x greater than or equal to 5. Because the largest number n is 6, we are going to calculate the sum of probability x equals to 5 plus probability x equals to 6. And the formulation is important, so we have 6 choose 5 times 1/4 p-value to the power 5 times q to the power 1 plus 6 choose 6 times 1/4 to the power 6 times 3/4 to the power 0. Eventually, this will be 1, this will be 1. So if you just write 1/4 to the power 6 here, that's also fine, because all of them will satisfy success, 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 etc. But it is important to incorporate this term as well. So 6 times 1 to the power 5 times 3 to the power 1 divided by 4 to the power 6 plus 1 to the power 6 divided by 4 to the power 6. Eventually, that's 6 times 3, that's 18, plus 1 divided by 4 to the power 6. Notice that the question says a divided by 2 to the power b. Therefore, we say this is 19 divided by 2 to the power 12. 2 to the power 2 equals to 4. Notice that, okay? A equals to 19 and b equals to 12. So that is the final answer. And then we can move on to look at the next question. Question 7, a simple polynomial equation. Then we have, okay, verify f of 5 is a solution. Make sure you show the calculation. 5 to the power 3 is 125, minus 5 times 5, that's 25. 16 times 5 is 80, so minus 80, minus 20. So eventually you have 125 minus 125, 125, so minus 125. So that's 0. Therefore, x equals to 5 satisfies. F of x equals to 0. It's one solution, okay? A solution. But then if you want to express f of x in the factorized form fully, you have to, let's say, do some algebra. I'll show you two methods. So if I show a 1 here, minus 1 here, minus 16 here, and minus 20 here. From previous part, we had 5 is a root. Bring down a 1, multiply 5 and 1, you have 5 here. Then you have a 4, multiply 5 and 4, you have a 20 here. Bring them down, add them up, you get a 4 here. And a 5 times 4 is 20, so minus 20 plus 20 is 0. Therefore, you get, let's say, x minus 5. Let me just write it properly. Should be f of x. This is a factorized form of f of x. X minus 5 is a factor. Then you have x squared plus 4x plus 4. That comes from, let's say, the coefficients here. And then this is a perfect square. You write x plus 2 squared times x minus 5. Okay? There are other valid methods. I'll put something down here. For example, you might use long division. But long division is very straightforward, so I won't repeat it here. Or there is another, let's say, inspection method. For example, if you say f of x equals to x to the power 3, because x minus 5 must be a factor, you can write minus 5x squared plus 4x squared instead of minus x squared. And then for the minus 16, you can write it like minus 20x, then plus 4x minus 20. Eventually, this is called a factorization by grouping. For the first two terms, you take out x squared, x minus 5. And for the second term, you take out a 4x. You still get x minus 5. And for the last term, you plus 4 times x minus 5. So it will lead you to the same result, x minus 5, x squared plus 4x plus 4. And that's why you get x minus 5, bracket, x squared, actually, x plus 2 squared. Okay? Right, any valid method should be fine. And then let's move on to the last question, or last part. The graph f of x, because we know f of x is going to be x plus 2 squared times x minus 5. Therefore, this will be minus 2, because it's the repeated factor, a turning point to touch the x-axis. This obviously is 5, and this will be, let's say, f of 0 equal to 2 squared times minus 5. So that will give you minus 20. You can also see that from the expanded term, okay? Expanded form. Okay, g of x is x plus 2. State the coordinates of the stationary point of inflection for the graph of f of x times g of x. So we let h of x equals to, let's say f of x is x plus 2 whole thing squared times x minus 5 times g of x is a linear function x plus 2. So you can bring x plus 2 together, you get x plus 2 to the power 3, this is a triple factor, times x minus 5. Therefore, the stationary point of inflection is minus 2, 0. Next thing is you want to solve this product function to be greater than or equal to 0. You consider, let's say, the graph of this polynomial. We have minus 2 here, and also we have a 5 here. So eventually we have an S shape here, and you get, let's say, another, concave up bit for a quality graph. Therefore, for this one to be greater than or equal to 0, you have this bit, and you have that bit. Writing them in, let's say, interval notation, you have minus infinity, round bracket to minus 2, square bracket, union, square bracket, 5, comma, infinity, round bracket. Union is important, not intersection. Also, you can write x less than or equal to minus 2, or x greater than or equal to 5. That is another valid way to express the answer, because the question didn't say you have to write that in interval notation. Question 8. Question 8 gives you, let's say, a linear function for a probability density function. Okay, Because it's a linear function, we want to find an unknown to have the probability or area 9 over 16. X, if it's greater than k, it's the same as greater than or equal to k. Now, if you draw a graph, for example, this is x, this is y. When you sub in a 0, you'll be able to get a 3 out of 8 times 4. That would be 3 out of 2. So let's label a 0, 3 out of 2 here. If you sub in 4 and 3, notice if this is 0, x equals to 4 over 3. So actually, this is 4 over 3, comma 0. And that'll be 1, 2, 3. Let me just. 1, 2, 3, 4. Each grid is 1/3. The next thing is, this straight line is the effective part here. Also, if we address the probability density function fully, you have a 0 part and a 0 part, okay? So altogether, it's a triangle, isn't it? And if I find some magic k over there, x equals to k, this point will be k, comma 3 out of 8, 4 minus 3k. And I just want this area to be 9 over 16. So let's say the width or base equals to 4 out of 3 minus k. That'll be 4 minus 3k divided by 3. The area of triangle equals to half times base, 4 minus 3k divided by 3, times the height. The height is the y value at x equals to k. So you can just construct an equation. And also the area is not 1. Let me just change that. It's 9 over 16 because it's not fully encompassing the whole triangle. It's just a smaller triangle. What else should I say? Oh, actually, this one is not so bad. 3 cancelled with 3. You will have 4 minus 3k whole thing squared divided by 16. That will be 9 over 16. Notice 4 minus 3k squared is the same as 3k minus 4. We can switch them around as long as it's an even power. It's equated to 9. So you have 3k minus 4 equals to plus or minus 3, and 3k equals to either 4 plus 3, that's 7, or 1. K equals to 7 over 3, or k equals to 1 over 3. But remember, k is a particular x value. We must reject this one, as k belongs to 0 to 4 out of 3. Obviously, 7 out of 3 exceeds this thing. The function h is a transformation of f such that h is mf plus n. Find the integral here. So the integral 0 to 4 over 3, we have m times f of x plus n dx. Don't forget about dx. Now m and n are constant, so we can write m lots of 0 to 4 over 3 f of x dx plus another integral 0 to 4 over 3 n dx. N is another, let's say, constant. Notice that f of x, if we integrate that from 0 to 4 over 3, the area must be 1 because it's a PDF. So we just have m times 1 plus, let's say, n times x between 0 to 4 over 3. Integrating a constant, get nx. Then you have m plus 4 over 3n. Or you can write 3m plus 4n divided by 3. Okay? So that's something you might want to write down. Another way you might want to write this one is 1/3, 4m plus 3m in a bracket. Anyway, so many different equivalent answers, but eventually the same thing. The page is blank, but examination continues on the next page. Then consider two functions. This is a rectangular truncus, and this one is a turning point form quadratic. If w equals to minus 3, find the 4 solutions. The question told you explicitly 4 solutions. So you get, let's say, minus 3. Actually, minus 3 squared is 9 divided by x minus 1, whole thing squared, equals to x minus minus 3, that's plus 3 squared. Then you can multiply both sides by x minus 1 squared equals to 9. Notice that you can now take let's say, a square root of both sides. You get x plus 3, x minus 1 equals to plus or minus 3. Then case 1, you will get, for example, let's say, x squared plus 2x and minus 3 equals to 3. So you get x squared plus 2x plus 1 equals to 3 plus 1, that's 7. I'm completing the square on the left-hand side, so x plus 1 equals to 7. So x equals to, for example, minus 1 plus or minus square root of 7. Case 2, you get x squared plus 2x minus 3 equals to negative 3. So you get x squared plus 2x equals to 0. Therefore, x plus 2 equals to 0, x equals to 0, x equals to minus 2. So altogether, you have 4 solutions. All right, this one is a fairly straightforward biquadratic equation. Next one, consider the case where w is greater than 0. Find, in terms of w, the coordinates of the minimum turning point of the graph. Because this is a quadratic, w is also greater than 0. You have a 1 here, you might have a w here. I don't know where it is, but it has to be, let's say, greater than 0. By symmetry, the turning point, x turning point is w plus 1 divided by 2. And the y turning point must be, let's say, w plus 1 over 2 minus 1 and w plus 1 divided by 2 minus w. So this thing will be w plus 1 minus 2 divided by 2 and a w plus 1 minus 2w divided by 2. So eventually you can take out, let's say, w minus 1 divided by 2. This will be 1 minus w divided by 2. And let's simplify this a little bit. If we take out a negative a quarter, 2 times 2 is a quarter, you will have w minus 1 squared. Question says coordinates. We can write w plus 1 divided by 2 and a minus quarter w minus 1 squared. Okay, hence or otherwise find the positive values of w for which f of x equals to g of x has exactly 3 solutions. Now, I cannot assume w equals to minus 3, but what I can do is I'll put a w squared here divided by x minus 1 squared equals to x minus w squared. So that will lead to, let's say, x minus w squared times x minus 1 squared equals to w squared. The next thing is I may get, let's say, x minus w, x minus 1 equals to w, or x minus w, x minus 1 equals to negative w. One case is, well, if you have this graph, you analyze from previous part. W is like a horizontal line. So can I get the turning point to touch, let's say, the horizontal line? If that's the case, the y turning point equals to minus a quarter w minus 1 squared equals to w. So w minus 1 squared, if we multiply both sides by minus 4, equals to minus 4w. And w squared minus, let's say, 2w plus 1 equals to minus 4w. Therefore, add 4w both sides, we have w squared plus 2w plus 1 equals to 0. W plus 1 squared equals to 0. The question says w is greater than 0. I can't really take this case. W equals to minus 1 rejected, as w is greater than 0. The other case, well, we might get, let's say, the turning point, let's say, touch the y equals to minus w, okay? Well, we could have, let's say, minus a quarter w minus 1 square equals to minus w. So w minus 1 square equals to 4w, and w square minus 2w plus 1 equals to 4w. So w square minus 6w equals to minus 1, and w square minus 6w, well, looks like a w minus 3, so we add a 9 both sides, we get 8 here. And w minus 3 squared equals to 8. W minus 3 equals to plus or minus root 8 or plus or minus 2 root 2. Notice that 8 is less than 9, so root 8 is less than root 9, which is 3. Therefore, 3 plus or minus 2 root 2, they are both positive. That's why the question, I suppose, is saying find the positive values of w. There are 2 values. So that's pretty much everything I need to go through for this mathematics exam 1. Hopefully you find it enjoyable. Well, I'll be waiting for tomorrow, the exam 2. All the best. I'll see you later.